In this video, we're going to factor perfect square trinomials, which are just usually quadratics, but they have a special characteristic. And so before we start, I want to take just an expression here, and I want to show you where a perfect square trinomial comes from. It comes from, since it's a perfect square, it comes from multiplying something times itself, just like any perfect square. 4 times 4 is 16. 16 is a perfect square because it came from multiplying a number by itself. So if I take this expression, 2x minus 3, and I multiply it by itself, so I'm just going to rewrite it here. I don't necessarily have to do this, but it can make simpling a little foiler. It can make foiling a little simpler if you're not real used to foiling. So I'm not going to show how to foil here. That's something that if you don't know how to do, I would recommend you look at another video. Foiling is just distribution. It's the opposite of factoring. So I have something that's factored, but here I'm going to put it all back together. So first is going to be 4x squared. The last two terms make negative 6x. The inner two terms make another negative 6x, and the two last terms make a positive 9. When I combine like terms, this is what I get. We know this is a perfect square trinomial because it came from multiplying something times itself. So let's look at a specific characteristic, a test that you can use to test if something is a perfect square trinomial. They always have this characteristic. If you take this middle coefficient here, don't worry about the sign, just take the coefficient, the number part of the coefficient, and cut it in half. So that'll give us 6, but I'm writing it like that for now. If you cut it in half and then square it, that will equal this coefficient times this coefficient. Okay, let's see if this is really true. Well, 12 divided by 2 is 6. 6 squared is 36. 4 times 9 is 36. This passes the test for a perfect square trinomial. So say you were given this to factor, which means you're given this and you want to get here or here. These are both the same thing, obviously. We usually go to here, though. Okay, you're given this and you're told factor it into this. Okay, well, can we look at the pattern here and figure out a fast way to go backwards to this? Well, we can. This here is going to be equal to, well, looking at this, I'm just going to make a parenthesis and put a square on it. Where do these two things come from? Well, if I take the square root of the first term, that's square root of 4 is 2, square root of x squared is x. Okay, think about it. X squared is a number that comes from multiplying x by another x. So the square root of x squared would have to be x. Square root of 9, 3. Now I take this sign, the middle sign, and I put it here, and I'm done. I have taken this and factored it to this. Now, if I hadn't spotted it as a perfect square trinomial, if I just saw this miscellaneous quadratic and I was asked to factor it, and I didn't notice it was a perfect square, then there's a way to do that without the shortcut, but it's a lot longer and more tedious to do. So anytime you recognize a trinomial as a perfect square, factoring is so much faster and easier. Let's do another one. Okay, does this meet the test for a perfect square trinomial? Well, let's take half of the middle coefficient. Again, not worrying about the sign. And let's square it, and we want to see if that equals the first coefficient times the last constant. Well, half of 12 is 6. 6 squared is 36. 3 times 12 is 36. Sure enough, it works. So we know this is a perfect square trinomial, but a big caveat here. whenever you factor any trinomial anytime, the first thing you should always do before you do a specific factoring technique is check and see, is there something I can factor out of all of the terms before I start another technique? In other words, a general factoring. Well, I look at this and I see I can actually factor a 3 out of everything here. So that's going to be my first step. Okay, so that 3 is still going to be sitting there when we get done, but now I have a simpler quadratic to factor here. This is still a perfect square. If you take half of 4, which is 2, and multiply it by 2, in other words, square it, you get 4. That's equal to 1 times 4. So it's still a perfect square. So now we're almost there. All we have to do now is, I'm going to put that 3 there, but now we put our parenthesis and a square, and I'm going to take the square root of the first term, square root of the last term, and that sign, and we're done. That's it. We have factored this. If you FOIL and distribute the 3 back in, you're going to get this back. Okay, is this a perfect square? Well, let's take half of 8 and square it. And let's see if that equals 1 times 16. Well, half of 8 is 4. 4 squared is 16. And sure enough, this is a perfect square trinomial. So I'm going to erase this 1 back off here. I just wanted to make the point that don't ignore the fact that you really are multiplying 16 by the coefficient of the first term still. It's just a 1 though. Okay. Well, to factor this, there's nothing I can factor out of all 3 terms before I start. Okay, actually let me go back to the previous color. I don't want this to get mixed up. Okay, I'm going to take this square root of x squared, square root of 16, and that sign, and I'm done. This is now factored. Okay, let's do another one. Okay, let's do the test. Does half of 24 squared equal 16 times 9? Well, 16 times 9 is 144. Actually, let me do it like this. Okay, well, half of 24 is 12. 12 squared is 144. 16 times 9 is 144. This passes the test. This is a perfect square trinomial. So all we do to factor it is parenthesis and a square root of the first term, that's going to be 4x. Square root of the last term is 3. Put this sign down here, and we're done. Okay, so I'm looking at this and I'm thinking, okay, everything here, I can factor a 2 out. So let's do that. 50x squared minus 20x plus 2. Okay, but now I'm looking at it and I'm realizing I could have actually factored out more because I can cut everything in half here again. So I did that to make the point of always check and see, have you factored out everything you possibly can. So if I cut these all in half again, okay, now I'm ready to go. So my factorization is going to be a 4. That's going to be sitting here. And I guess we should test this first. Okay, is this part in the parentheses a perfect square trinomial? Well, if I take 10 and cut it in half and then square it, does that equal 25 times 1? And 10 squared, half of 10 is 5. 5 squared is 25. Sure enough, that equals 25. We have a perfect square trinomial. So I know that all I have to do now is take square root of 25, square root of x squared, square root of 1, bring that sign down, and I'm done. Let's do one more. So this here, you'll notice it has two variables in it. So we have an x squared and an x, and then we have a y and a y squared. So one thing that you can do here is just, I'm going to concentrate on the x squared and the x. And we could turn this in for n, and we could concentrate on y squared and y. But since it's already written with the x squared on the left, I'm just going to go with x squared. And what I'm going to do is I'm going to just pretend that the y is like any other number. I'm going to pretend it's not a variable. So I'm going to switch the x and the y here. Because I want to do something here. So again, we're just kind of pretending y is just a number, that it's not really a variable. And we're thinking of everything in terms of x. And so what I'm asking myself here is, okay, so now I'm going to call this the number in front of x. And so I'm going to take half of it and square it. And I want to know, does that equal the first coefficient times the last number? Well, here I'm thinking of that whole thing as the last number. So I'm going to think 4 times 9 y squared. Okay, well, if I cut 12y in half, that gives me 6y. Okay, so I'll square this in a minute. 4 times 9 times y squared, that's 36y squared. Now, when I square this, I'm going to get 36. This is 6 times y times 6 times y. That's 36y squared. And sure enough, we have a perfect square trinomial. So now we can go back here, and I'm looking, there's nothing I can pull out of every term, so we can go ahead and go straight to it. So I'm going to just put my parenthesis in a square, and since we've determined it's a perfect square trinomial, I can take the square root of the first term, which is 2x, and the square root of the last term, which is 3y, and take the middle sign, and I am done.